Hi, welcome back to the series part two, the first video of the part two of the series. What we're going to do a few things. We're going to pretty much reiterate a couple different things that we did in part one as far as those topics and projects and videos. And we're also going to add a few wrinkles as well for part two of the series, just to make sure we have these things really nailed in. Now, for the first video, what we're going to do is going over some encryption and hashing and different ways of doing those as far as different algorithms within those to make sure that we have proper security hygiene as far as making sure that the integrity of the data is properly configured, right? So, and we also understand how these things work. So we're actually going to go over some cryptographic basics, some hashing algorithms, and some hash values. So let's go ahead and get started with the first exercise. All right, so the first exercise is going over cryptography basics. I'm not going to do too much explaining. I'm just going to get right into it because I feel like I did a lot of explaining on the part one. So let's actually go ahead and get started. Let's open this up here. What we're going to do is actually download the crypto demo here. So let's get to our tools. Go. I'm a bit under the weather, so sorry about where. All right, so we have that taken care of. Let's open this up here. Okay. Should be fine. Go. We should. All right, perfect. So now we can see the program in the start menu, right? And we can see the same program once it's been open. So now we're ready to continue with our crypto demo encryption. So we're going to apply the encryption algorithm, the 3DES, to see the output and begin to recognize what such an output generates in terms of values. And this, in fact, helps even experienced people recognize different algorithms just on plain sight, right? So again, I believe on the last video, we did a bit of study in the interface itself, which is designed to assist in practicing and learning more about encryption in particular. So let's actually we're going to keep it at the triple 3D, the triple D DES. So I'm actually going to type in key here. Let's see. Then let's do perfect. Okay, so we entered some text in the data field, right, to be encrypted. Welcome to Dunder Mifflin, one of the greatest shows that was ever created. So now I'm just going to press the encrypt button to see the result of the encryption here. And if we notice, no matter how many times we click encrypt, it's going to change a bit, right, as far as the encrypted data. So as many times as we like, we'll see different results of output data, right? And this is one of the most important concepts behind encrypting a text, right? And a ciphertext should be different and unreadable, right? So now we're going to get into a bit of crypto demo decryption. So after encrypting the plain text with the crypto demo, we can actually decrypt the content and make sure it has the same content as originally intended. So to do that, I'm only going to delete only from the data field, right, containing the written text that I entered, and I'm not going to change the key or the algorithm type. So let me actually do that there. Actually, let me do that. All right, perfect. So we see that all the data, at least the written text data, is deleted, right? So now I'm just going to press decrypt. And as you can see, it still interprets the data as what the original text was. So we can try different types of encryption algorithms as well. We'll try to just a singular DES encryption, right? And we can try RSA, right? And we can also try RSA RC2, right? And we can also delete some character data from the more encrypted data, the encrypted data here. That was the last, at least. Let's see if we delete just a few characters. It'll still encrypt. And if we decrypt, it'll still decrypt into the original text. Right. So now we can actually move on to our next hash, which is going to be key values, right? So in general, we can mix up as many variables as possible with long string lengths, which produces a strong key to encrypt or hash against, right? So we're going to use some options presented of random key and time key. So we're going to apply these to key formats to see the results. So previously we input our own. However, in reality, this is actually a poorly secure key, and a better option would actually be able to generate a random or time value key, which is a lot more secure. So I'm going to actually delete the contents of the encrypted data here. And I'm going to try a random key. We see that also changes as well to see what we're presented with. And it's not going to match the images neither with our time values, right? So now I'm going to delete the encrypted data and then hit the time key. And you can see obviously the time just changes with whatever times or second that it is, right? Right. So actually I'm going to hit encrypt again, time key, then encrypt. And once more we see another output, right? Which differs from the first result. So now we can actually swivel over to hashing, right? So it's just a value to use to map data of any size and provide a method for verifying the integrity of verifying the integrity and also the authenticity of data and the authors. So we're just going to apply the same tool to see hash results. So if we put the hash here, get hash, no value. So let's see. Spell. Again, if you know, you know, right? So just within the top field, I wrote something a bit different, but unlike the encryption stage before, the hash will not change if we press the button. So let's do the hash. No matter how many times we click it, it's going to remain the same as far as the hash value, right? So from the hash algorithm drop down, I'm actually going to change it to SHA-1, right? Hash algorithm, and that's going to change. So you have to change the hash algorithm itself between M2, MD2, MD4, MD5, and SHA-1 in order to get a different result for each algorithm, right? But now that we've seen this showcase, we're going to move on to our next exercise, which is going to be comparing hashing algorithms. So now that we have a look at a different variety of algorithms in direct comparison, right? Using HashCalc, which is a calculator that pretty much computes message digest checksums at HMAC for files as well as for text and hex strings, right? We're actually going to take a look at it. So we're going to learn a bit more about installing HashCalc and actually using HashCalc. So let's see, it should be here. Go, buddy. Now I'm just installing it. The quickest install I've ever seen. I wish all installs were like that. All right, so we take a look at the format here, right? It's slightly similar to the crypto demo, right? It's a bit more constrained a bit, at least to me. I like to have a big window to take a look at things, right? But it only has a small or smaller window. Rather, so we take a look at the data format. Let's actually change this to the text string so we can actually enter something else here. Yeah, I remember when Jim moved away to take another, well, he didn't move away, but he went to another division or something like that in the series. I forget. But nonetheless, I entered some text in the data field, right? So after this, I'm just going to make sure I check all of the boxes here so we get the different algorithms. with the hash calcs. And if you notice, I only checked these in the middle here, and I'll get to the HMAC and the eDonkey in a later task. But now I get to calculate to see our results, and we have different hash algorithms all on one thing here, so one dialog box. So we can change the data in the field to anything we like here, and we can see the different values of hashes compared to each other, right? And we'll notice that essentially the different algorithms produce hashes of like set lengths, which we use to identify them. So now I'm going to check the HMAC value. And then actually, I'll leave it at the text string because the hex, I'll get to that in a second because that's a little bit different. Well, a lot of bit different actually. So now we'll only see a specified amount of hashes that will be permitted, right? So just because the keyed hash message authentication code is specifically uses hash functions. So within the HMAC, we can actually edit the key format to allow text or hex string, but we're gonna, again, continue to use text strings. So if we do, just copy paste here, we see that again, right? So we can keep, calculating. Again, it's a hash, so it's not really going to change. It's only changed based off the algorithm that's being used. So now I'm going to change the key format to hex, right? Now for hex string, it actually has to be an even number, right? So it's like you can compare it to a pair of socks. Like you don't for it to function properly. You're not going to put on one sock and you'll be fine with that. It's going to feel super weird, right? And it's the same or similar concept to HMAC as far as at least the hex string version of it, as far as the formatting, for it to calculate anything. Because if I knock one off, right, it's going to give me, it must be even, right? So then we calculate again, and we're good to go. So we're actually able to, let's see, we do a file. I want to take a look at the different data formats as well as the key formats too. So we look at we can load a file actually to hashcalc to be evaluated. So let's actually take a look here. There's a shortcut to PuTTY. Should be here. Let's see. That's the only one, yeah. Okay, perfect. So let's actually, dang it, I wish I can open this up a little bit more. We can actually see the different versions of it, right? As far as the hashing algorithms for the data that we've opened, at least for the file rather, for the shortcut to PuTTY, right? So yeah, so we continue to calculate. Again, nothing's going to change. It's just going to remain constant as far as the values. So we do this here, still the same, right? But yeah, nonetheless, that's just how that works as far as hash calculating and the different ways of doing that between different formats, key formats, data formats, and things of that nature. So now we actually, for our last exercise, we're going to compare hash values. So we're going to compare them to get a better understanding, right, of how hashes visually compare to each other in that state. So we're going to be grabbing some website hashes and also using an online comparison tool. So let's actually grab the website. Let me actually close this out. All right, so often each website, right, has a hash value of the program that's authored. So the values are made by the author, of course, and we can use it to confirm the integrity of the programs or files. Let's actually get straight to it. Oh, what was part? Try something. So I copied it prior to. There it is. All right, perfect. So we're looking for the PuTTY beta 067. Let me know if you guys see it. I don't. Okay. There it is. How you doing? All right, save. Okay, it's actually run. That's fine. All right, perfect. So actually, let me delete that. All right, so actually, let me see. I'm going to look for two files to check again. So we're actually going to look for MD5 here. All right, and then I'm actually going to, let me go back. Tab. Actually, you know what? No. I'm going to do window. Then let's do window. And of course, we're greeted by the long list of hash sums for each algorithm, right? So let's see. Take these down. Just compare them, right? Well, this is the manual, long, arduous way of doing it. All right. But yeah, so we can now see the different algorithms between MD5 sum and SHA. Right. So now we can use the online comparison tool. So that's actually going to be, I have to go back to here. Perfect. Okay. Maybe that issue. All right, let's fix that. All right, so we got our site up and running. I had to use an alternate link in order to get everything up. So now we're just going to compare the values, right, for both the MD5 and the SHA-1 found on the prior website, right, that we grabbed those from. So using this product, I'm actually going to start with, let's see, the file checksum here. Uh, let's see. Actually, let me go. So, okay. All right, so we can actually, you know what? I may not need that. We can actually do, let's see. Mm, You know what? Yeah, I'll use the hash calc. I'm all over the place. Sorry about that. Let's go to, send it's not where I thought it was. That's fine. Close that here. I'll just use this one. And we can compare it to another one that I have. And that actually I'm going to put, it's not what I wanted. I'm just going to, what an asshole. They're two different algorithms, so there. All right. So I was slightly I'll put for a second. So what I did was I uploaded the checksum file without necessarily uploading it from when I downloaded the PuTTY installer. And from the file checksum, I compared it with the checksum from the website not here, but these two here. Then I compared it. I saw that it worked. So I did it with MD5. So I'm just to continue with the example, I'm going to do it with SHA-1 as well. So let's do this one here. All right. And then stop. And then let's see, have the hash calc, use that as well. Because I used the same file that I uploaded here to the online comparison calculator to also generate the MD5 and SHA-1 hash algorithm. So I'm gonna just put that here. We compare. Oh, let's see, SHA-1. There's it here. For some reason, all right. Let's see. We can actually check further with 250s. Well, we can do that. Let's see. One switch. So this one is actually good. So we can close this guy out. Let's see what's going on here. Actually, oh, no. Not ideal. There it is. So it's there. Not sure what's going on. Of course, I'm pretty seconds. Let's see. That's typically how you would do a file comparison, at least. Just looks a little muddy on why. Not sure if it's the calculator or if it's user error. Naturally, most of the time it's user error, right? As far as why it's not doing what it's supposed to. Check here. Or just it's two. There's one, and then there's the shortcut. Pick the shortcut. There it is. And clearly we know it's on here as well. Right here. So yeah, so that's the comparison. Even with the small hiccup, we were able to verify the integrity that it was actually the same hash configured by the author. So this is the end of the video. Sorry about the little snag at the end. But just for a brief recap, we went over cryptography basics, hashing algorithm basics for comparing them, and also comparing hash values as well. This is going to be, again, a reiteration to some extent of the part one, just to really drill down these concepts. So in the next video, we're actually going to go over SCCM configuration items and baseline, which should be even more fun than this current video. Thank you again if you did watch all the way through. Stay curious, stay secure.